Hello, good morning, no? And we have an application again of the derivatives of functions, no? So we will be solving problems in the maxima, minima problems. So previously, no, we are given the idea and finding the extreme points on the curve, no? So we have the maximum or minimum point. So these points have practical applications in many areas, which is referred to as the maxima minima problems. These problem or they may be problems of practical use or theoretical interest. The following steps may be helpful to solve a maxima minima problem. No? Now right here, we are not given a function for us to differentiate. So that is why, out from the condition of the problem, then you have to read and understand the problem carefully. So we have to draw the figure if needed and introduce the variable quantities like x, y, z or other letters in the initial quantity it represented such as A for area, V for volume, and T for time. Identify the quantity to be maximized or minimized and express it in terms of the other variable quantities. Now, if possible, you have to form a function with only one independent variable. So find the first derivative of the function and set it to 0 because it is there where there is a maximum or minimum point. Solve for the roots of this equation. They are the critical numbers which will give the desired maximum or minimum function value. The critical number may be subjected into tests like the SDT or FDT, but in practice, they may be verified only by inspection. Okay, so inspection is just enough to determine whether these critical numbers can be made the function maximum or minimum. Now, suppose we are given a situation like this. There is a closed cylindrical tank which is to be made having a fixed volume V. So your V here is not a variable but it is a constant. What is the relations of its height h and its base radius r if the cost of making it is less? So we have to minimize the cost of the construction of this kind of cylindrical tank. Okay, so we have a solution. So following the steps of solving, so I try to read and understand the problem well, and I know that I have a closed cylindrical tank with a fixed volume V, and I have to work finding the relationships between H and R. So here is my figure. Now, so we have a right circular cylinder, so this is my altitude H, and this is my base radius R. Now, so I have the base, no? So the top and bottom sides, no? And then we have the lateral area also here. Now, we have to determine the quantity to be maximized. So we have to minimize the surface area because the material to be used will depend on the surface area of your cylinder. So we have to minimize the surface area to have a minimum cost needed must be less. Okay, now what is the surface area of your tank? The surface area of the tank can be represented with S, okay? Or maybe A, so S na lang, no? Because that is a surface area. Okay, so we have what's that? EL, what is EL? That represents the lateral area, the side here, no? And then, we have the AT, and that is the area at the top and the area at the bottom. Okay, what is the area, the lateral area of your circular tank? Now, if this is circular, no? So, as if imo nang gikat diha, and you have to stretch, no? So, the length of which represents the circumference. What is the circumference of a circle? That is equal to, what is the circumference? 2 pi r, no? So, that's 2 pi r. Just multiply with the altitude h. Okay, so this is now the value of your areas, no? So, we have 2 pi r. That is the circumference multiplied with the height. No, as if this is being cut and that is being stretched, no? So there you form a rectangle. So where the length of which is the circumference, which is 2 pi r, and the height is h. Now area at the top is circular, so that is pi r squared. Then bottom is also the same, that is pi r squared, because the area all throughout the section is uniform, which is circular, and it is pi r squared. So these terms are similar, so we can combine. No? So 2 pi rh plus 2 pi r squared. No? So now, this is involving, your is involves two independent variable, the r and h. Your r appears twice, no? And your h is appearing once, no? With the power of 1. Now, you have to find a way to reduce your r in terms of h or h in terms of r. So I can look for further relationships between the two. Now, what is the use of mentioning the volume of the cylinder? The volume of the cylinder by formula is equal to area of the section multiplied with h. Correct? Okay, so area is pi r squared times h. So, I think it would be easier to solve for h than solving for r, because if I'm going to replace my r in terms of h, then I need r with power 1, I need r squared. No? So, I have to express na lang my s as a function of r. So, what is h? H is equal to v over pi r squared. So, you substitute this to your surface area. The surface area is equal to 2 pi r. So, your h can be v over pi r squared. And this can be simplified because there is h and there is r. That's common. Okay, so we can remove that one. So, what is the result? We have 2v over r. Second term, I copy the second term. That is 2 pi r squared. Now, your s is not expressed in terms of v and r because your v is a constant. So, the only variable here is r. So, it is expressed as a function of the base radius r because v is a constant. Okay, now, you are now ready to differentiate your surface area with respect to its independent variable r. So, ds dr. Derivative of my first term is minus 2v multiplied with 1 over r squared. So, just recall your formula of differentiation related to c over u to power n, or if not, you can also consider the power rule of differentiation. Derivative of r squared is 2r. That's why we have 2 pi r. And we can let the derivative, no? After evaluating this, we can set that to 0 and we can solve for r. By the way, for the formula in the first term I'm using, so this is the formula that I'd use, no? We have the derivative of c over u to power n where I have a negative c. The negative c is minus 2v multiplied with a ratio, so n over u over n plus 1. So what is your n? Your n is 1. So that's why I have 1 over r squared. R has a power originally 1, so I increase it by 1, so that becomes r squared. Okay? Now, plus the other term. Derivative of the other term under a power rule. Now, setting the derivative to 0 and simplifying. Okay, now, this is my ds dr. Okay? Now, there is a denominator of r squared. So, if I multiply this with r squared, no? So, we can have the 4 pi r cubed. Then, I have minus 2v in my first term. And I simply transpose. And that's why I have 2v equal to 4 pi r cubed. Now, there's 2 that's common. So, I divide with 2. So, dividing with 2, you have 2 pi r cubed. And that's equal to v. Okay, now, simplifying further, I know that my v can be equal to pi r squared h. Okay, now, to gain or to obtain more relationships between r and h. Now, r squared is part of this. So, I can reduce. My pi is totally removed. So, what is left is 2r equal to h, or h is equal to 2r. Now, what is the significance of this result? In constructing a closed cylindrical tank, the altitude of the tank must be equal to twice its radius, or twice the radius is equal to the diameter of the tank, so the height must be equal to the diameter. That is, if we consider the cost of construction to be minimum. No? So, height must be twice the base radius, and this is a proper proportioning. Now, if you look at some formula books, no, you will find, no, that there is already a variable relationships, no, where there is a maximum minimum value of the function. So, it is actually derived on similar manner as this. Okay, now, how to apply the relationships of h and r that we were able to identify in problem number 1. So, you are given a situation here where you have the same tank, a closed cylindrical tank, but the capacity of which is already specified. So ana siya moingog fixed volume, but it is a fixed volume where there is a specific value. So the volume of the tank is 256 pi expressed in cubic meter. Now, you are required to find the dimensions requiring the least amount in the material. Now, if we do not know that the altitude must be equal to twice r, then you will be following the same process as how we arrive with h equal to 2r. But since I already have a proper proportioning, and this is the advantage if you know how to derive formulas, no? So you can arrive with the relationships of variable where there is a maximum and minimum value of the function. So today, we try to minimize, of course, the cost, no? When you construct, so you have to minimize the cost in order that minimizing the cost, no? And you can still attain the desired capacity of the tank. Okay, so of course, no, when you design a tank, no, or you design any structure, your consideration is to deliver what your clients need, no, wherein it will be at a minimum cost and at the same time, you will be after for the safety of your structure. Now, using the proper proportioning, what is the proper proportioning? The height must be twice the base radius. Okay, so this is my tank that I'm going to construct. Now, if this is the altitude h, no, so wala maputol imong tank. Okay, so this is h is equal to 2r. So meaning, ang imong diameter here must be the same as the height of your tank. That is constructed in a proper proportion. Now, we are given a volume, and we know that the volume is equal to pi r squared h. Now, in proper proportioning, h is equal to 2r, so my h is now replaced with 2r. So, my equation will only involve r, and you can solve for that. Now, so pi is out, and I have sa r cube. Dividing with 2, so I have 128 r cube. So, taking the cube root of this equation, both sides, no? So, I have a cube root of 128, which will give you your r. So, calculating, we have a value. So, 5.05 approximately. And twice the value will give you the value of your h. So, multiplied with 2. So, there I have 10.08 approximately in meters. Now, or you can write up to the last digit of your calculator. Okay, so this is the dimension that we are going to provide, no? Wherein we can give the desired volume, no? And the cost of the fabrication will be less. Now that you know this, no? So your mind will now be exploring, no? Okay, you might be thinking, what if the can of your sardines, no, will be proportion? What is the cost, no, difference, no, if it will be constructed that way? Now, by the way, in the construction of this tank, no, our consideration is that, no, that the cost and the area involved here are all the same for the side, top, and bottom. So, we consider a uniform costing. No? Now, when you consider costing, you also have to consider the unit prices for top and bottom. No? So, initially, ato lang i-consider. So, as our mind tries to explore, no? So, is there a variation in the cost, no? And the can of sardines, no? Wherein the proper proportioning will be considered. And when you will be looking structures around you when you go home or at your neighbors or maybe in your own home, no? So, if you see a tank like this, no? Which is a closed cylindrical tank, again, your mind will be thinking, no? So, is there an application of the derivative of functions? Is there an application of calculus where we consider the minimum cost of its construction, no? So, makita nimo imuhang mga tangke des inyong dool, no? So, is the base radius equal to the height, no? So, if not, then there is something maybe wrong in the construction. So, you have to consider cost, no, as your consideration. At the same time, you have to consider the safety of your structure as a designer. Okay, now, let's proceed. Another problem, you are given a rectangular field that is to be enclosed and subdivided into 5 equal lots by fences parallel to one of each side. If a total of 10,000 meters of fence are available and will be used Find the dimension of the largest field that can be enclosed out from the given length of the fence. Okay, now, as a common geometric figure, what is a common geometric figure here? We have a rectangular field. Okay, so I have to draw the figure because it's needed for me to analyze my problem well. Okay? So, by looking or reading and understanding the problem, so this is now the figure that I constructed. There is a rectangular field and then this will be subdivided into 5 equal parts. Okay? So, maybe this belongs to Winifredo, this belongs to Manuel, to Joselito, sus ang mga ngalan no mga karaan kayo Adolfo marang-arang ning usa timing no Emilyn no now dili na lang ako tawag ingon ana no to make it shorter I call this as lot A, lot B, lot C, D and lot E. Now pwede sa imong balihon no A lot, D lot, C lot, B and A lots. Okay, now proceed. Now, the dimension of your rectangular field is X and Y. Okay? So, I need to maximize the area to be enclosed by this field. No? By this fence, I mean. No? So, what would be the maximum area that can be enclosed by this fence? No? So, area is equal as a product of X and Y when it's a rectangle. The problem here is that ang atong area is expressed in terms of two independent variable. Okay? So, expressing that in terms of a single variable, so I have to consider the given available length of fencing material. So, to express into one independent variable. Okay, now, I have two sides having a length of X and I have a length of Y which is actually how many? There are 6 vertical Y's. Okay? So, my equation can be 2X plus 6Y equal to 10,000 meter length of fence. Now, there's a common factor to simplify my equation. I divide my equation with 2. I have X plus 3Y equal to 5,000. So, I may solve for Y or I may solve for X. So which is good to solve? I think it's good to solve for X because if I'm going to solve for Y, my equation may contain fractional terms. No? So in order to avoid that, so I have to solve for X instead of solving for Y. Okay, so it is 5,000 minus 3Y. I substitute this to my A so that my area will be expressed in terms of Y. So area is equal to X which is 5,000 minus 3Y multiplied with Y. So in order to avoid the use of a product rule, so I try to distribute my Y. And I obtain this. Okay, so my area is now expressed as a function of Y. So, derivative of A with respect to Y, first term becomes 5,000. My second term is 6Y. Equate to 0, I solve for Y. That is 5,000 over 6 which can be reduced to 2,500 over 3 meters. So, this is the value of my Y. And I can solve for my X by going back into X equal to 5,000 minus 3Y. So, it is 5,000 minus 3 times 2,005 over 3. So, there I obtain, this is again wrong. Wala ko makorrected, no? So, this is again 2,500 meters. Okay? So, this is my answer. Okay? So, this is corrected in my dimension here. Okay? So, this is 2,500. Okay? So, 2,500 meters by 2,500 over 3 meters being my dimension. Okay? So, bigyan mo ng konting pasensya, Susel, no? So, I missed to edit this part. Okay, now, let's proceed. There is an isosceles trapezoidal gutter, no, whose lower base is 16 centimeters and the sloping sides are both 8 centimeters. What is the width of the upper base in order to have the greatest carrying capacity of the gutter? So we know what's a gutter. Now, usually, asa na ito makita? So they can be found if that is a rain gutter, no? So ana sa ato ang kabalayan, no? Okay, now the section of our gutter so is like this. Okay, so we have this as an isosceles trapezoid. Okay, I reflected the given like the base length, lower base, having a length of 16 centimeters, and the upper base width, no, is the one which is required, and that is W. So the sloping side is of the same length. That's why we call this as an isosceles trapezoidal gutter. So 8 centimeters each. Okay? So this can be a variable angle when it's needed. Na? So this is 8 centimeters. Now, if we will be changing the height, so the value of x is also affected. No? So if you have to lower this, no? So your x may be extended, no? Padong dito. No? So these two are actually variable quantities, including the angle can be a variable value. So what is fixed is the base length of 16 centimeters. So if that is 16, so this is a variable x, and this is a variable height. Now, in order that the carrying capacity will be greatest, dapat the section of your gutter will be maximized. So we need to maximize the area. Okay, so to have a greatest carrying capacity of the gutter, you have to maximize the area of the section. Now, what is the area of a trapezoid? That is equal to 1/2 of the lower base plus the upper base multiplied with the altitude h. Okay, so this is now the formula, no, applied. 1/2 of multiplied to 16 plus the W, and the W is equal to 2x. Okay, are you following? Plus 16. Okay, so all of this, no, is multiplied by h. Now, if we have to simplify, no, so we have 2x plus 32. Now, if you factor out your 2, then you will arrive with 16 plus x. Okay? But 2 can be eliminated with 1/2. So, your area is equal to a quantity of 16 plus x multiplied by h. So, again, there's a presence of two independent variable, your x and h. So, I can look for the further relationships, no, of x and h. Now, take note that there is a right triangle here. Okay, so if there's a right triangle, then I can apply our Pythagorean theorem. Okay, what is our Pythagorean theorem? H squared plus x squared is equal to the square of it, and that is 64. So what is h? We have 64 minus x squared. Take the square root of that. Okay, and substitute to your area. Area is 16 plus x multiplied with the square root of 64 minus x squared. Now, after expressing 2 in terms of a single independent variable, so that's the time we can take the derivative of a according to product rule. So 16 plus x multiplied with the derivative of a square root, so there I have. So we have plus the square root of 64 minus x squared times 1, and set the derivative to 0. Now there's a common factor to, so I tried to remove that one. So there is a minus x left, no, with 16 plus x in the numerator of this ratio. To further simplify, I tried to multiply with the denominator. My denominator is the square root of 64 minus x squared. So only the minus x can be distributed to 16 plus x. And I obtained this. Minus 16x minus x squared plus 64 minus x squared. And the square of this, no, that is taken out from the square of this. No? So ganito, atong i-distribute, I have the first two terms, and this one is the result when I take the square of my irrational term being multiplied with the same irrational term. Okay? Now, x squared is combined, and I transpose to make it plus. So we have what's that? 2x squared minus 16x becomes plus 16x, no? Then, again, we have a negative 64. They are actually placed on the other side of my equation. Okay? Or if they are left on one side, 0 at the other side, and then it's multiplied with a negative 1, and I obtain this term. So, to simplify further, I have to divide with 2. So, I obtain this one. Then, I solve for my roots. My roots can be, so we have two values. 2.928 centimeters, and I use this because the other value is at negative value. Actually, there is a function in your calculator dealing with equation in second degree, so we can go directly with this result. Now, after knowing the two values of x, and I simply disregard the other because by inspection, this is the only value that I can use. No? Okay, so use the x1. So I substitute to my w, and my w is 2x plus 16. So 16 plus twice the value I solved, then I arrive with 21.86, which is the required width of the upper base. Now, the problem may be solved this way, using trigo functions. Now, if you notice in our figure ganina, we were not able to solve for the angle. Or we may not able to use the angle, the variable angle here. Because if you have to change your h, you have to change your x, no? Then the angle will also be changing. So this is variable quantity. Okay, now how to use a trigo function in working with the maximum cross-sectional area. Okay, ngayon. From the figure, I consider my right triangle in order to use my angle theta. Sine of theta is opposite side, correct? H over the hypotenuse of it. So, solving for your h, it's a product of it and sine of theta. My x can also be reduced in terms of theta. Okay? So, cosine of theta is adjacent side. The adjacent side is the same as x, correct? That is adjacent side over the hypotenuse side. So that is x over 8. So x is a product of 8 cosine multiplied with the cosine theta. Okay, now I can go back to my w. W is equal to 16. This is the required 16 plus 2x, correct? In terms of theta, my x can be on 8 cosine of theta. So this can be 16 plus 16 of the cosine theta as my w. So if I can determine what is cosine theta, then I also have the value of w. Now, I need to maximize my area. My area of the section is equal to 1/2. Okay? So 16 lower base, this is your w. And multiplied with the with the altitude h, and my altitude is equal to 8 sine of theta. Now simplifying this is 32 plus 16 cosine theta. There is a common factor. What is your common factor here? 16, correct? Removing 16, you have 2 left, and this becomes 1 cosine theta. So 16, is it 16? Yes. So 16, if that is factored out, no? So by the way, where did I obtain 4? That is 8 divided by 2, that is 4. I obtained 64 because I tried to factor out 16. So 16 times 4 is 64. And we have 2 plus the cosine theta multiplied with the sine theta. So my area is now expressed in terms of the angle theta. So you are now ready to differentiate your A with respect to theta. So 64 as a constant. So we can have the product of the function involving theta. So we have 2 cosine theta. The cosine theta is the derivative of sine theta. Correct? Okay, then plus the sine theta multiplied with the derivative of the other factor. So 2 becomes 0. And the derivative of cosine is the minus sine theta. Equate this to 0. I remove my 64 because if I'm going to divide with 64, then that is already out. That is if the common factor here is a constant. Now, if the common factor involves a variable, no? So never divide with that common factor involving a variable, or else you are eliminating some roots of your equation. Okay? So you can only divide or remove the constant factor common, no? When it is a pure constant. Okay? So what is left here is 2 cosine theta. Now, when I distribute that one, I have cosine squared and minus sine squared. Now, in our trigo equations, no, we can find the roots of a trigo equation if we have to reduce that in terms of a single trigo function. So, there is an application of identity that the sine squared can be 1 minus cosine squared. Now, combining terms similar, I have on that 2 cosine squared, okay, then plus 2 cosine theta, and that's minus 1. So solving for the cosine theta, we have two values. Again, using equations and second degree to solve for the value of the cosine theta. So this is quadratic in the cosine function. So my cosine theta is minus 1 plus the square root of 2 over 2, and the other root is minus 1 minus the square root of 3 over 2. Now, for the values, no? So I tried to use this, or I'll be using the first one because this is the one which will give us a positive result. The other one which will give a negative result, so I simply ignore that one. No? Now, my W is equal to this, and out from the cosine theta, no, which is, I'll be using the exact value, so I come up with this, and my W is obtained to be the same as the previous. So the width of the upper base is equal to 21.86 centimeters. Now, here is another problem. So, this is an application of the inverse trigonometry. The lower base of a picture is 4 feet. The upper edge of which is 9 feet above the observation point or the eye of the observer. At what horizontal distance should it stand if the angle subtended by the picture is a maximum? So this is a maximum viewing angle. So here is the picture, and this is the eye of the observer, and this is the point at which the observer has to stand. Now, and this is a variable distance. So if the observer will be moving, so the angle here will also be changing. So this is a variable angle. Now, in relation to the angle that is formed, no, between the line of sight and the horizontal line of sight, so this is my theta 1. My theta 1 is paingon sa lower base di ay mong line of sight, no, and theta 2 is from the horizontal line of sight. So these are angle of elevations, correct, in our trigo. So we have theta 2 and theta 1. So the angle subtended must be maximized, and from the figure, we know it is a difference of theta 2 minus the theta 1. How to solve for the angle theta? I can consider trigo function. I can maybe consider the tangent of this angle of elevations. Theta 1 is opposite, which is 4 over x. So I try to use tangent in order to use the given height and the variable distance which is required, which is x. No? So theta 1, I take the inverse trigonometry. That's the arctan of the ratio of 4 over x, of 4 and x. No? So tangent of the secant angle of elevation, that is also equal to 9 over x. Opposite is 9 over x. Okay? And theta 2 is equal to the arctan of 9 over x. Now, going back to my theta, so it's a difference expressed in terms of the arctan function. So it is the arctan of 9 over x minus the arctan of 4 over x. So I can now differentiate my theta with respect to the distance, the differential of the distance required. So we have 1 over 1 plus u squared, 81 over x squared. So minus 9, no? Then this is actually the c over u to power n form. Okay, so minus 1, or you can have a power rule where you can express this as 9 multiplied with x to power minus 1. Can be. So this is the result differentiating this. Try to follow the formula previously mentioned in the other problem. No? And minus 1 over 1 plus the square of 4 over x. Then again, we have the same rule na minus 4. So n, the power here is 1 over increase the exponent of your x by 1. Okay, equated to 0. Now, removing my denominator, I multiplied with the LCD, which are these two denominators. Okay, I have minus 9 multiplied with the quantity x squared plus 16 and 4 multiplied with the x squared plus 81. Okay, so simplifying by distribution. So these are the terms I obtained. I combine my x squared term, and my equation comes out to be minus 5x squared plus 180. Dividing with a negative 5, I have x squared. This is a negative 36, and that is being transposed. So taking or extracting the square root, I have plus minus 6, so I ignore my negative value, and my answer can be 6 meters. No? So kine, you have to stand 6 meters from the point directly below the picture frame. So this will have a maximum viewing angle. Okay, so thank you for watching. And I'm inviting for those who are new in my channel to subscribe, no, and share this to others. Okay, so bye-bye, and I hope you enjoy watching.